Hello and welcome to the second webinar on FlexiSoft. In this webinar we will be looking at the function blocks within FlexiSoft. My name is Iain Keetley-Smith. I am one of 3 functional safety engineers at SICK UK. The others you may have heard of are Seb Strutt and Martin Kidman. We also have a number of sales engineers who are trained up to functional safety technician level, so you're rest assured whoever you're talking to in SICK, you'll be talking to somebody who has knowledge of safety systems. So the agenda for today's webinar is first of all to understand different programming languages. The second one is where do you find the function blocks in FlexiSoft Designer. The third item is the blocks in general, so we're going to just not look at every single block in FlexiSoft Designer, otherwise we'll be here all day. So we're going to concentrate on AND and OR logic gates. We're going to look at reset blocks, EDM, which stands for external device monitoring, the RS Flipflop function block, routing blocks, and muting blocks, and finally delays, on and off delays. Then we'll look at where you get more information, and finally we'll look at the future webinars that we're running. So first of all, the most programming languages used when configuring industrial controllers are mainly ladder logic, so you'll be familiar with this if you're used to programming programmable logic controllers. And in here you can see the push button is represented as a normally open contact, and then on that first rung there you can see Q0.0, and that's representing a normally closed contact, and the element at the end is the switching device that you're switching. So hopefully that is familiar with most of you. If you're not familiar with ladder logic, there is plenty of information on the internet covering ladder logic, so I'd advise you to go and have a look there. The other type is structured text, and that tends to take the format of if, not, when, then, and things like that. So you can see there's an example of a structured text program. We then have what's called sequential flowchart, and that's when the coding takes the form of a flow and you program each block individually, but you can see it running through the flowchart as you're executing the program. And the other one that we're looking at is function block. So this is a typical sort of layout here of function block of a PLC, and if we now take a look at the FlexiSoft controller, you will see this is the format that it takes. So it's hopefully easy enough to understand, and we'll be going through some of these blocks later on in the webinar. So where do you find the function blocks in FlexiSoft Designer? Well, if we just open up a new project here, and once you click on create new project, it will start to initialize the software. And once the software has opened up, we will then get a choice of CPU. So for this example, I'm just going to bring in a CPU 0, which will come into the configuration area. And once that's come in, we will then select input-output card, an XTIO. If you click on elements, we can then add devices to that hardware. So in this case, we're going to add a dual channel e-stop and a reset push button. You can see them populating on the controller. And then the outputs, we're going to select a motor and finally a lamp. Now if we go up and click on the logic editor, you will see that the inputs are available to us here that we've just assigned, and down at the bottom outputs, there's the outputs that we've assigned, and between the two of them we have function blocks. If you click on there, you'll see a list of all the function blocks that we have within FlexiSoft Designer, and we'll be going through some of these later on. So you've got resets, restarts, edge detection, there's your delays. In there we have counter, cycle, clock generators to create pulses. We then have EDM, external device monitoring, muting blocks and press blocks. Then we have other, which allows us to get a bit more control of the inputs, and then we have some customized function blocks there as well. So that is where all of your function blocks reside in FlexiSoft Designer, if you didn't already know. So, understanding the function blocks. Let's first have a look at the AND, the OR, and I'm going to add in here what's called the XOR, which is exclusive OR gate. So here is the familiar look here when we're in the logic editor. So what I'm going to do is come over and select an AND gate and drag it over, and you will see here we have input 1 and input 2, and then we have an output from that block. If you double click on the block, you have the option to invert the input. So if you need the inverse, you can tick that box there. If you go to I/O settings, you can see there that it's got 2, but you can actually have up to 8 inputs on an AND gate. Just to make it easy, we'll stick to 2. We can add comments in, and finally information. The information tab is an extract out of the user manual, which will give you a description of how the block works, which is very, very handy to have rather than going in trying to find a manual. It's all built into the software. So over here we're going to go to inputs, and I'm going to drag over the e-stop push button and connect it onto input 1. I will then drag over the the safety switch, attach that onto input 2. We will then go to the outputs down at the bottom there and select the motor. Now the great thing about FlexiSoft is there is a simulator built into it which will help us understand how these blocks work. So if we click on these 3 bricks here, we will start the simulation mode, and then we hit the play button, and when it's green it's logic 1, when it's 0 it's white. So you can see you have to have both of the inputs green, logic 1, to get the motor running. If I activate the e-stop, motor goes off, e-stop goes back healthy again, motor on, and likewise with the safety switch. So that is the AND gate. You have to have both inputs healthy to get an output. If we now have a look at the OR gate, I'll just drag this over here, and again double click on the OR gate, and you have the same tabular format at the top here, so you can invert inputs. You can change the number of inputs to 8, but we're going to stick with 2 just to keep it nice and simple. You can go to I/O comment, where you can change the name, and information like before gives you details on the OR block and the truth table. So we'll say OK to that, and we'll just assign the e-stop and the safety switch to those 2 inputs there as well. And on the output, I'm just going to grab this lamp and touch that on output 1. There we go, and we'll go back into the simulation again. So you'll see the difference here when running the simulation is if I just activate the e-stop, the lamp comes on straight away. So I have to have one input or the other input at logic 1. With the OR gate though, if I have 2 inputs high, then I still get a high. There's your AND gate working as it was normally there. So you can see here, there's your e-stop and your safety switch high, and your output stays high. So one or the other. To get the lamp off, we have to have both off, or one. We can have both. So hopefully that helps you understand the function of the OR gate. Now we'll have a quick look at the exclusive OR gate. So the exclusive OR gate is still an OR function, but you'll see the difference with this is that when you get both of them high at the same time, the OR gate goes to 0. Now I haven't got an output here, so you can see that output 1. So if I have 1 on, then the OR gate is high and the exclusive OR is high. There we are, that's high with the green there. If I have both of them high, then the AND gate's okay, the OR gate's okay, but now because I've got both high, output 1 on the exclusive OR is off. So that's the difference between an OR gate and an exclusive OR gate. So hopefully that was understandable. As I say, you can easily get these blocks over, double click on them and have a look at the truth tables for them. But I just thought it'd be useful to show you the difference between an OR gate and an exclusive OR gate. So the next block that we're going to look at is, or before we move on actually, let's have a look at a typical application. Because a lot of people think to themselves, why would I want to use an OR gate? So let's have a look at this example here. So we have a robot which is palletizing onto the pallet there. Once the pallet is full, what will happen is the pallet will then move along the conveyor, go through light curtain 2 and go onto an area where the forklift truck can come in. Now if we look at the truth table for this, if light curtain 1, which is where opposite the forklift truck, if that is broken, then it will stop the conveyor and it will stop the robot. If light curtain 1 is broken and light curtain 1 is healthy, or sorry, light curtain 2 is healthy, then the conveyor and the robot can work as normal. And if light curtain 1 is healthy, you can see it's got 1, 1, and the truth table there, it's got light curtain 1 is at logic 1. Light curtain 2 is at logic 0, but the conveyor and robot can still run because the primary light curtain, which is light curtain 1, is still active. So we don't need to do any muting or anything fancy on light curtain 2. All we need to do is that light curtain 2 can be broken constantly as long as light curtain 1 is clear. So I hope that makes sense. It's just to give you an example of where you may use an OR gate. So let's have a look at the reset next. So again, we'll open up our logic editor, and in this case we will go over and we will bring in an e-stop push button, and then we will bring in the reset. And in your function blocks down at the bottom between inputs and outputs, if we go to the start edge, you'll see there's a reset block there, so we'll drag that over and drop that down and then play a game of join the dots. But as always, there is a block here, so you can change the input-output parameters, you can change the IO comment, and in information there is our good old information on the block and how it works. And if we keep scrolling down, you will find that there is a timing diagram which describes how the block works. So all the information is there. So we'll click on OK there, and then we'll play join the dots. So we'll take the reset and we will smooth these out of the way a little bit and join them up. So reset to reset, e-stop to release. We'll then go to our outputs. We'll select our motor, touch that onto enable and drag it back. It will automatically draw the line. And then we'll grab our lamp, touch that on reset required and drag it back. Now if we go into the simulator again, just to show how this works, and put it into free run, and if the e-stop is healthy, then the reset required lamp will flash telling you a reset is needed. You press the reset push button and then you release it and your motor starts. If you press the e-stop push button, the motor stops. Put the e-stop circuit healthy, reset required lamp flashes, reset, on and off, and your motor runs. So hopefully that describes the reset function. Now what I'm going to show you here is, imagine you've got two inputs. So in this case we've got the e-stop and the safety switch. There's two different ways of doing this. What I'm going to do first of all is we're going to take the e-stop and the safety switch. So we're going to say that the e-stop and the safety switch have to be healthy. So we join up the dots here and get the lines nice and straight, take the output up to release 1 and run the simulator. So with this one you have to have the e-stop healthy and the safety switch healthy, then you get an output to release 1, press reset, release it, and your motor runs. If you open up the safety gate, the motor stops, put it healthy again, reset required, reset, and we're off and running again. Now, that means you're using two software blocks. What if I could make that into one software block? So I double click on the reset, go to I/O settings, and in there I can change the number of inputs to 3. Well, all the way up to 8 in total, but we're going to choose 3. Say OK, and then join the dots up, or join the line up there, move the e-stop up to there, put the safety switch on there, and now run it, and the code will work in exactly the same way as it did before, but rather than using two software blocks, we're just using one. Now you see it says release condition fulfilled. That is the result of that AND gate. So when the AND gate isn't healthy, release condition goes off, then release condition comes on, reset required, and your motor runs. So if you've got a customer who is using lots and lots of AND gates into reset blocks, we can optimize the code by maybe trying to increase the number of inputs on the reset input block. So that's just a sort of quick sort of expert mode there you can try in the future. So that's your reset block. The next block we're going to look at is EDM, which stands for External Device Monitoring. Now, just to get an understanding of what EDM is, here's a typical relay circuit. So on the right hand side there, where that arrow is pointing to K1 and K2, so you've got your voltage coming through your fuses, and for example you've got 13, 14, 23, 24, so that is your safety contacts, and when your input is healthy and everything is okay and it's reset, K1 and K2 will energize. Now you can see that we're monitoring K1 and K2 there in what's called the EDM circuit. So when K1 and K2 are energized, then the contacts that are shown there, K1 and K2, should open. When K1 and K2 de-energize, then K1 and K2 contacts should close. So basically the safety relay is checking to make sure that K1 and K2 have not got a fault in any way. For example, if they had a welded contact, the safety relay wouldn't allow you to reset. So what it is, it's just a checking circuit. It's for diagnostics. So how do we do that in the FlexiSoft controller? So let's go and have a look at this here. So first of all, what we're going to do is go over to potential free contacts and restart, and we're going to add in there external device monitoring as an input. So we just add it into the hardware. Once we've added it in there, it'll become available in the software, so you can see it over on the left hand side there in black. I'm going to delete this line, which is to the motor, move the motor out of the way. I'm then going to go to my function blocks, go to EDM output blocks, and there's a function block called EDM. So I drag that over and drop it down. I take the enable to the control, and I take the motor to output 1. I'll then come over, select my EDM inputs, that's the normally closed input from that motor contactor, and that's that there. Now when I go into the simulation mode, what I need to do is make sure that when the motor is off, that the EDM input is high. So it's always the opposite. When the motor's off, that is high. Now I put e-stop and safety switch, get my reset required. I have to just stop the simulator, press the reset, step at 200 milliseconds, and then release the reset push button, and the motor will come on. Now that's come on, that has to go off. So it always has to be the opposite. Now it'll run fine. Now if I activate an input, the motor will go off, and what we're going to do is not change that. And what you'll see is the block goes into error, and you get an EDM error at the top right hand corner there that you can send to a PLC or to an indication lamp to tell you you've got a problem with the contactor. So that is your EDM block. If you double click on it, it defaults to 300 milliseconds as the delay. You can change that if need be. And as always, you can go to info, and that will give you details of how that function block works. and also how the timing of that block works. You've got to be careful with the block when you're simulating logic, because if that goes into error when you're in the simulator, the only way to clear the error is to go out the simulator and come back in again, which can make it quite difficult to work. So that was the EDM. Next one is the RS Flipflop. So for the RS Flipflop, what we're going to do is go over here and drag it in, and you've got a set input, a reset, a queue and a not queue. I'm going to bring over a couple of normally open contacts. So there's a normally open on set, there is a normally open on reset, and then what I'm going to do is go down to outputs, and I will bring a motor in and attach that onto queue. And then we'll go into the simulation again once we've gone through this, so you can invert those if you want, put comments, and again there's your extract out of the manual. So off to the simulator, and if we blip the single channel normally open on the set, so switch it on and off, so switch that on and switch it off, you'll see that it's latched. So Q output is latched and the motor's running. The only way to unlatch it is to do a blip on the reset. So that's basically the RS flip-flop. So if you get a pulse coming in, it sets it high, and then you need to have another pulse coming in to reset it. And what we'll do later on is we'll be combining some of these blocks into the final circuit that's shown. So hopefully the RS flip-flop is easily understandable. A lot of people sometimes use it as a reset block because they're not familiar with the reset block that we looked at earlier. So it can be used for that if you've got pulsing signals that you want to latch. So moving on, we'll look at routing blocks. So for routing blocks, what we're going to do is there's two different types of routing blocks. So I'm just going to draw a quick circuit here. There's an E-stop, there is a reset. I'm going to go to my reset block and bring that in, and then I'll simply just join the dots up here like so. Then go to my outputs, and I've got my reset required lamp, and I've got two motors here that I want to switch. So I bring my two motors over, and just pop that there, and there we are. And then we join the dots up. There's one motor and there's the other motor, but whoops, it will not allow me to connect two motors to one enable output. So how you get round that is if we delete that line, you go over to your function blocks. We'll just move this down a little bit, give me a bit more space. Push these out the way. If we go into function blocks, under logic you will see we have routing 1 to n. So we drag that over, and we're now going to double click on it, and you can have a maximum number of 8 outputs out of a routing block, but we're just going to stick to 2. Again, comments and your information is available to you. So we take the enable to the input, we then take motor 1 to output 1, and motor 2 to output 2. So now we're able to switch 2 outputs from one enable. The other routing block is a routing end to end where we patch the signals through. So again, you can go in here and you can have up to 8 inputs and 8 outputs. If you choose number of inputs, number of outputs will automatically change. And there's your information. So we'll say OK to that. And what we're going to do here is just bring over the E-stop and touch that onto input 1, bring over the reset, touch that onto input 2, and we're going to do something here which we might cover on later on in the series, but we're going to add what's called a jump address. I'm just going to call this E-stop, and that means I can use that flag, it's like a flag or something like that, or a marker. I can use these elsewhere in the program. So that's just routing signals. So hopefully that that covers the routing blocks. Like I say, the information is in the information tab if you need it. The next block is muting. Now we've got various muting blocks built into FlexiSoft Designer, but we're just going to look at the crossbeam one just for a simplistic point of view. So in the hardware here, I've put a light curtain on here, a couple of muting sensors, and I've also got a reset down here, a motor. I've got a reset required lamp, and I've also got a muting lamp. So I'll go into the logic editor and I will bring over my light curtain. I'm also going to bring over my two muting sensors. Just simply drag them over and drop them down. There is my reset. I shall bring that over and put that down there. And if I go to my function block, the first block I'm going to do is get a reset block and attach that there and just join the reset up to the reset input. So down here we've got our light curtain and muting sensors, so we're going to go to our muting and press blocks, and you can see we've got sequential muting, parallel muting, crossbeam muting. So we drag the block over, and if I just move that over there, you can see all the labels on there. So your light curtain goes at the top, you've got muting, override, conveyor, and then you've got your various outputs from the block as well. When you double click on the block, we get different settings here. So muting end condition, you can end it on the sensors or you can end it on the light curtain. We're going to end it on the light curtain. We're going to set the total muting time to 10 seconds. For concurrency monitoring, suppression of sensor gaps, we'll cover that, or you can read about that by going into the help menu. But I'm just disabling all of some features just now just to try and make the block more simpler. So down here it'll describe all about muting, it'll describe all the parameters that you can set, and then it will also give you the timing diagrams there as well down at the bottom. So we'll say OK to that, so just go and read that at your leisure. So we'll now join up the muting sensor, so muting sensor 2 to A2, muting sensor 1 to A1, and we will connect our light curtain to the light curtain input there. We'll then take the enable out of that block into the release of the reset block. We'll go to outputs and we'll grab a motor which goes to the enable of the reset block, and we'll grab the reset required lamp, pop that on the reset block, and then we'll take the muting lamp and attach that onto the muting lamp output from the muting block. So that's us all done. Go into the simulation, and if we run the simulator, if we put the light curtain healthy, a reset required is asked for, so we press the reset and release it and the motor runs. Now if we come down and break the light curtain, the motor stops. Put the light curtain healthy again, reset, and motor runs. If I select muting sensor 1 and 2, the muting lamp comes on. I can now break the light curtain and make it, and you can see the motor never went off. Now we ended the muting on the light curtain. If I select 2 and break the light curtain, and now we wait 10 seconds, after 10 seconds it will go into error and the motor will stop. There. So to clear it, you need to get the muting sensors off, light curtain good, and we're off again. So it is that simple to do a cross-beam muting of a light curtain. As I say, there's other muting blocks available to you, and you can add more functionality into these blocks if need be, but for this purpose I just did a simple demonstration there. So that's our muting cross-beam function block. The next function block we're going to look at is the delay on and delay off. So in this one I'm going to use a solenoid locking gate switch. I'm also going, there's the solenoid lock down there for the gate. Go into the logic, and first of all I'm going to bring in the interlock switch. I'm then going to bring in the reset block, and we're going to grab a reset as we have done many times before. Join those up, and There we go, join it up. Now we go to our outputs. Now on here I have got, there's my reset, you can see there's a variable speed drive, so I've got an enable on the variable speed drive, and I've also got safe torque off. Now what I'm going to do is bring in a delay off. So I want to put the drive into a fast stop by taking the enable off, and then 2 seconds later, just so this shows in the simulation, you'd probably go for less than that, I'm going to take the safe torque off signal. So what will happen is the enable will go off instantly and the safe torque off will go off 2 seconds later. Now the other thing I'm going to do is I'm going to have a request to enter push button, because I want to request entry into the cell. So I am now going to choose an RS flip-flop. So there is our RS flip-flop, because this request to enter is just a push and release button. I then go to my delays and I'm going to go for an on delay this time, and I take the output Q to the input of the on delay, and this time I'm going to set this to 5 seconds. So the gate will unlock for 5 seconds. If it isn't unlocked, or if the door isn't opened within those 5 seconds, the door will relock. That is what we're hoping for. So there's the output to unlock the door, and that's my 5-second timer. I'm going to take that to a jump address, and I'm going to name this jump address timer 5 seconds, say OK, join that up to the enable. I will then take that 5-second timer into the reset for the RS flip-flop. So what will happen is I will join that up. We will then go into the simulator, as we've done many times already, and we'll run the simulator. So if the door is closed, then I'll get reset required lamp flashing. I press the reset push button and release it, and my drive can now run. So you can see that there. And down here I request to enter, which is a press and release. 5 seconds later the unlock goes off. So you can see the unlock came on and off there. So press it, release it. I can now open the gate. As soon as I open the gate I lose the enable. 2 seconds later I lose the safe torque off in the drive. I close the gate, which automatically relocks, press start, reset, and off we go again. Request to enter, unlocks the gate. 5 seconds later, you haven't opened it, so it relocks. So that there is a typical circuit. So we're using on delays, we're using off delays, we've got our reset block, and we're also using the RS flip-flop. So that's just a typical circuit where you've got a solenoid release gate switch, and you want to request enter, and if you don't open the gate within 5 seconds, the gate will automatically relock and the machine will keep running. So that is us. So that's the only logic blocks I was going to look at today. If you do want to look at more function blocks, by all means go and download the software from our website, which is a free download, and you can get that from going to the SICK website. So you just go to the downloads tab along the top there and type in FlexiSoft. If you want more detailed information, it's on the webinar, the first webinar that I did, which will actually show you how to navigate to download the software. And there are also software manuals and hardware manuals in the FlexiSoft range, which give you all the details that you need. If you're more of a visual person and want to see people doing things, then we have the YouTube channel, and in there we have a dedicated SICK YouTube channel. So just click on the magnifying glass there, the search icon, type in FlexiSoft, and again you'll be able to get access to more information on FlexiSoft and all the features of it. For future webinars, I say webinar 1 is currently being recorded, and you can view that offline. Just get in touch with us and we can send you the link to view that. This is webinar 2, which was looking at function blocks. Our next webinar is going to look at configuring a FlexiLoop project, Webinar 4 is looking at what's called FlexiLink, which is connecting multiple CPUs together. Webinar 5 will look at FlexiLine, which again is connecting CPUs together. We'll then look at diagnostics. We'll look at what you can get out of the FlexiSoft standard PLC to reduce the downtime and hopefully increase productivity. And then finally, Webinar 7 will actually look at a robot palletizer application and put a whole project together showing you how you go about doing that. So they will be coming out in the future, and once they have been done, then there'll be a recorded version available to view offline at your heart's content. So thank you very much for your attention, and the details of myself are there. So Iain Keetley-Smith, you've got my email address and my direct mobile telephone number there. And if you can't get hold of me, then there's Martin Kidman details there as well. So I tend to look after the south of the country, and Martin looks after the north of the country. But if one of us isn't available, then we'll cover the whole country. So it's hopefully if you email us or contact us, we'll get back to you very quickly with any questions that you have. So thank you very much for your attention, and have a good day.